Hello and welcome in this lecture. In this lecture, we will study about bits and the difficulty in Bitcoin blockchain. Bits and the difficulty, they are very related to each other and they are very important in understanding about how we will be having 21 million Bitcoins in 2140. So we always say that after that year, there will be no new Bitcoins generated. Okay. So in this lecture, we will see how bits are converted to target hash, how target hash is related to difficulty. Right. So our main aim of this lecture is to understand bits to difficulty to target hash. Okay. So for this, I will extract the real values from the Bitcoin blockchain itself. So I will just open any Bitcoin or blockchain explorer that will help us to understand. So for this, I will take some values from bit. There is one explorer called as SmartBit. After that, I will go to first block, and after seeing the bits value there, we have 1D 00 FF FFF 4 times F. So I will try to explain how it is converted to target hash. Okay. So what we have here, we have 1D00FFFF. So total target hash, there are 256 bits, right? Because we are using SHA-256 hash function, right? So our target hash will be 256 bits, that is 32 bytes. Okay. So what this value reveals here, it says 1D in hexadecimal is equivalent to 16 to the power of 0 to D plus 16 to the power of 1 into 1. That is, D is equivalent to 13 in hexadecimal, right? So this is equivalent to 1 and we have 16. 16 plus 13, it's 29. So this value says that we have 29 bytes and the rest of these bytes will say these are the most significant bits for 29 bytes. So total we have 32 bytes, right? We have 32 bytes, but this thing will that, okay, this is only 29 bytes and those 29 bytes are starting with these bytes, that is 00 FF FF. 3 bytes are this. Okay, so remaining bytes are 26. These are 3 and we have 3 bytes as a prefix also. Now total 26 plus 3 plus 3, that is 32 bytes. Okay, so we have 32 bytes now, right? But first 3 bytes are blank. This thing gives no value, but this gives that we have 29 bits, 29 bytes from there. and these 29 bytes are starting with 00 FF, and rest 26 bits are, we will fill them with zeros. Fine. And these 3 bytes will be also filled with zeros. That is, target hash is equal to, these are 4 zeros, 8, 16, 24, 32, I guess, because this is 1 byte, 2 byte, 3 and 4 bytes. 4 byte, 32 zeros. Then 16 Fs, then followed by rest of the zeros. So that we have total 256 bits. So now you understand how I changed, how I go from, I was at bits because these value are bits. Then I converted these bits to target hash. So we have target hash here, right? So this is our target hash. Fine. Now we have target hash here. We will try to understand this difficulty. So understanding about difficulty, we have seen how target hash was obtained. Now, as part of the proof of work, miners participate in a challenge where they try to solve a puzzle such that the hash of the block, the contents of the block, actually these are the contents of the block header, hash of contents of the block header plus nonce, it should be less than the target hash. And now you understand what is this target hash. So whatever the hash should be, it should be less than this target hash, or equivalent to this. So now we understand the target hash. We will see how difficulty changes, how difficulty is evaluated. Now since we calculated this target hash for the first block, Genesis block, so this is considered to be the T max, right? This is considered to be the T max. T max equal to 24 zeros, 16 ones, and rest of zeros. That is, we have 40 and we will get 216 zeros. Okay. Tmax is that, but there is a formula that the next target hash is equivalent to the previous target hash into amount of minutes it has taken to generate first 210th block. This is T in minutes. Okay, divided by 20160. Okay, I will tell you how these values are coming here. Just have patience. I will try to relate all of those things so that this will make sense to you. Okay, now 2160, the difficulty, or we can say target hash, is evaluated after the 14 days in Bitcoin. So 14 days equal to 24 into 60, and this is equivalent to how many minutes? 2160. Okay, now where from this 2016 value, why we are going for this? Because as per the Bitcoin protocol, as per the standard for the Bitcoin, it takes 10 minutes to generate one block, right? So 6 blocks in 1 hour. So by this logic, how many blocks should be generated in 14 days? It is 2016, because we are producing only 6 blocks per hour, and there are 24 into 14, 24 into 14 hours in total. So we will calculate 24 into 14 into 6, right? 24 into 14 into 6, it is 6 here. So that will be 2016. Now, if you see how things will work, now let us suppose 14 days are gone, right? 14 days are gone. Now we will see when was 2106th block mined. If it is greater than 14 days, right, then what will be the effect on the formula that we have? Tn plus 1 equal to T max, right? Tn, we are calculating Tn. Let's that just hold on for this formula first. I will try to explain the earlier formula first. So by this way, we were calculating next target hash equivalent to previous target hash, the minutes total time it has taken in minutes for this 206th block divided by 20160, right? So since I told you it is greater than 14 days, it is taking more than 14 days. What we say 2n is equal to n. Since it is greater than 14 days, it will be more than 1, because this value will be more than this value. So it will be 1 point something, we say. Let us take, for example, 1.1. So what we say, the next target is going to be the larger than the previous target hash. What is difficulty? Difficulty is, right, T max divided by Tn plus 1. But T max, you understand that the target hash for the Genesis block, that is the maximum value. Here we are calculating just after the previous hash, that was T max hour. This Tn is T max. Now if this is greater than the top value T max, then difficulty will be less than 1. But that, according to the protocol, according to the Bitcoin standard, difficulty is set to 1, right? And its value is set such that it is greater or equivalent to 1. It can't be less than 1. That means difficulty can't go less than 1. Fine. So for that, what we do to make it less than or equivalent to 1, we have to make the target hash lower, right? Lowering the target hash means we have to increase the difficulty, because since you understand, if it is greater than 14 days, then this situation was happening. So what we have to do, we have to reduce we have to make target hash smaller, so that difficulty will increase, right? So another scenario was, what if it is taking less than 16 days? Okay, if it is taking less than 16 days, then what will happen? The thing will happen that this will be lesser value, and this will be next T1 equal to will be, since it will be less than 14 days, this value will be smaller and it will be less than 1. Let us take this. That means next hash will be smaller than the T max. When next target hash is smaller, that means we know the difficulty is this, and Tn plus 1 is going to be the smaller from 2 max. Like if this is 1, this is 0.9, it will be like 10 divided by 9. So 1. Okay, it's 1.1. so difficulty will grow up. In the previous case, we were having the situation like it is going down to, it's going below 1, but according to standard, Bitcoin standard, it's always set to 1 or it is greater than 1. So 216 block, we have to check what will be the difficulty. If this block, if a layer 2016 block was produced in less than 14 days, then the difficulty will be more than 1. If it was generated in more than 14 days, then it will be, with formula, it would have been less than 1, but according to the standard, it is set to 1. So to validate this, in the same way, after next 14 days, we have to evaluate again. After 2610, we have to add it to 160. This is 12 13 0 4 4033. When was this block mined, right? If it is greater than 14 days from the previous 16 block, then we have to reduce the difficulty. If it is less than, then we have to increase the difficulty. By this, there will be like, it will be, the generation of the blocks will be balanced, and it will be it will be done in a constant rate, so that what will happen, we can predict the total number of we can predict when how many blocks will be produced and how many bitcoins will be, how much bitcoins will be produced. Let us try to demystify it again. We see, when Bitcoin was generated, when Bitcoin was invented, in first block was mined, it was very approximately in Jan 2009. At that time, mining reward was 50 BTC, right? But after 4 years, it gets halved. So 2130, we have 25 BTC, right? In 2017, it was halved to 12.5 BTC. In 2021, we have currently 6.25 as a mining reward. So this rate is also determined, fine. And the block generation rate is also determined, fine. Block generation rate is also determined, because 10 minutes we are producing one block. Okay. So 1 hour we are producing 6 blocks. 24 hours we are producing 24 into 6. In the same way, process goes, because this is maintained with the formula that I have shown, how difficulty bits are varying, so that the pace is maintained in a controlled way. By this way, we will get 2140. In this year, we'll have 21 million bitcoins, and that's it. Because at that time, if we see in 225, the half, and if we just half it, and it's like 3.12 something. In the same way, we will get 2140. We will have no mining reward. Total, we cannot, we cannot mine, we cannot create new bitcoins then. So we finally have 2140. 21 in the year 2140, we have 21 million bitcoins. So I hope you understand the process, of varying difficulties and all the things. And for this, you can see, I will show you how these are, these will make sense to you when you just look at the Bitcoin Block Explorer. You just try to see difficulty chart. From that, it will be clear. Just try to see difficulty chart. Fine. We'll see how first it was like, if it is 1, how it was for the many years. It was just like one, then it just grows like this. So it's difficulty, it's time. In the same way, so the bitcoins as a mining reward, it started from 50 and it goes half. It goes half here, it then goes half this, it then goes half this year, like it goes half this year, it goes half this year, and finally in 2140 it will be zero, and at that time total bitcoins will be 21 million, right? So to to just check all these things, I will try to show you one Bitcoin Explorer so that these things will make sense to you all, and you will better understand this. Okay. Like if I go to stats, see what is there. I just want to have difficulty information. I just want to this log scale because I want to have it. You see, you can see the value, it's going 0.4, but that is going 6.2. Just want to get it from right from the first block. Okay, just try to find from the first block. We just try to find what was the 0th block. Was there anything about the 0 block? Okay. And this was the bits that we were using. This was the bits we were using, right? Zero 1D 00F, we have used that. This is the transaction in the 0th block. Okay, so we have seen this. You can see from the tools difficulty we have seen. I just want to change the difficulty from just want to calculate, see how it was 0. It was 0. No, it's between 1. Since it is in log scale, we are not able to just see here. In 2009, it's 1. In 2000, this value is like the same thing. How difficulty is growing like this way that I have told you. Fine. So I think that's it. That's it in this video. I hope you were able to understand each and every concept regarding the bits and the difficulty. How we will have 21 million bitcoins in year 2140. So I hope you understand. If you have any question regarding this, don't hesitate to ask. Thank you. Thank you very much.